Hi to everyone, welcome to NCC channel. This is Naresh, chemistry teacher. Today I would like to discuss one of the concepts from haloalkanes and haloarenes. Then I will discuss what are the questions asking in competitive exams like JEE Mains, NEET, EAP set. If you watch this video to the end, you can get some idea how the questions asking in competitive exams from this concept. Right. Today our concept is halogenation of alkanes. Halogenation of alkanes. It is one of the preparation method of haloalkanes. First, I will explain the concept, then I will discuss some previous year questions. Right. So, hallucination of alkanes. So, what is hallucination? So, reaction with halogen is called hallucination. Reaction with halogen is called hallucination. Okay, hallucination of alkanes. Here, alkane or H. Alkane reacts with halogen in presence of sunlight, H nu. In presence of sunlight or in presence of high temperature, it produces haloalkane. It produces haloalkane. In this reaction, hydrogen comes out, halogen comes in. Hydrogen comes out, halogen comes in, it can form haloalkane. Here, hydrogen substitution takes place with halogen. Hydrogen substitution takes place with halogen. It is one of the substitution reaction. Right. It follows free radical mechanism. It follows free radical mechanism. And this free radical mechanism involves three steps: chain initiation, chain propagation, chain termination. So, but here no need to discuss here. Next step. So, it is a substitution reaction, it follows free radical mechanism. It follows free radical mechanism. Hence, this reaction is called free radical substitution reaction. Free radical substitution reaction. This reaction is called free radical substitution reaction. For example, I have taken alkane and halogen. I am writing like this: in presence of sunlight. In presence of sunlight. So CH bond undergoes homolytic cleavage and it forms R radical and H radical. In presence of sunlight, X bond involves in homolytic cleavage and forms XX radical, X radical. R radical combines with X radical, it forms RX haloalkane. So hydrogen radical combines with X radical, it forms HX. In this way, it can form haloalkane. For example, I have taken CH4. When treated with chlorine in the presence of sunlight, here one hydrogen comes out and chlorine enters. One chlorine atom enters. It forms CH3Cl. CH3Cl. The hydrogen which is coming out combines with another chlorine atom. It can form a byproduct HCl. Byproduct HCl. In this reaction, if you take excess of halogen, what happens? It forms further substitution takes place. Further substitution takes place and form dichloromethane, trichloromethane, tetrachloromethane. Like that, it can form a mixture of products. How can you prevent this? How can you prevent mixture of products? How can you prevent further substitution? For example, if you take excess of alkane, we can prevent further substitution and mixture of products, but not 100% we cannot prevent. Only somewhat we can prevent if you take excess of alkane, right? For example, here hydrogen substitution takes place with halogen and it forms haloalkane. The substitution of hydrogen depends on reactivity of hydrogen. Reactivity of hydrogen. So what is the reactivity of hydrogen? So 3 degree hydrogens are more reactive than 2 degree hydrogens. 2 degree hydrogens are more reactive than 1 degree hydrogens. What is 3 degree, 2 degree, 1 degree hydrogen, sir? 3 degree hydrogen, nothing but If the hydrogen attached to 3 degree carbon, that is called 3 degree hydrogen. If the hydrogen attached to 2 degree carbon, that is called 2 degree hydrogen. If the hydrogen attached to 1 degree carbon, that is called 1 degree hydrogen. Right. If the 3 degree hydrogen involves in homolytic cleavage, it forms 3 degree carbon free radical. If the 2 degree hydrogen involves in homolytic cleavage, it forms 2 degree carbon free radical. If the 1 degree hydrogen involves in homolytic cleavage, it can form 1 degree carbon free radical. So the order it forms carbon radicals. So which is what is the stability of carbon radicals? Stability of carbon free radicals. 3 degree carbon free radical is more stable than 2 degree and 1 degree. So 3 degree carbon radical is more stable. Hence the reactivity of 3 degree hydrogen is more. Here least reactive because it can form 1 degree carbon free radical. It is least reactive. Hence 1 degree hydrogen also least reactive. Right. I have taken one example. CH3, CH2, CH3. When treated with chlorine in presence of sunlight, here substitution, the chlorine substitution takes place at which carbon? It contains 1 degree carbon, 2 degree carbon, 1 degree hydrogens, 2 degree hydrogens. Which hydrogens are more reactive? Here 2 degree hydrogen is more reactive than 1 degree hydrogen. Hence substitution takes place at 2 degree carbon. If the substitution takes place at 2 degree carbon, it forms 2 degree carbon free radical. If the substitution takes place at 1 degree carbon, it forms 1 degree carbon free radical, which is more stable. 2 degree carbon free radical is more stable than 1 degree carbon free radical. Hence, chlorine substitution takes place at 2 degree carbon, CH3, CH, X, or chlorine, CH3. It is major compound. And if the substitution takes place at 1 degree carbon, it also forms product, but it is minor product, because if the substitution takes place at 1 degree carbon, it can form 1 degree carbon free radical. It is least stable, hence it is also the product also least minor. CH3, CH2, CH2, Cl. Here CH3 group, this CH3 group, both are symmetrical. If the substitution takes place at this carbon or at this carbon, same product, produce same product. For example, if the substitution takes place at this carbon, it produces 1 chloropropane. If the substitution takes place at this carbon, it also produces 1 chloropropane. Both, because both are symmetrical, right? It is minor product. Right. For example, I have taken CH3, CH, CH3, CH3. When treated with chlorine in the presence of sunlight, what will be the major product? Here, chlorine substitution takes place at which carbon? Here, 1 degree carbon, 1 degree, 1 degree, both these 3 carbons are symmetrical, right? This carbon is a 3 degree carbon, and 3 degree hydrogen is more reactive. Hence, substitution takes place at 3 degree carbon. CH3, CH3, Cl, CH3. It is the major. If the substitution takes place at this carbon, the product will be minor. So, the substitution takes place at this carbon or at this carbon or at this carbon, produce only one product because these 3 carbons are symmetrical, right? CH3, CH, CH3, CH2, Cl. Okay, it is minor product, right? Right. Now, for example, I have taken methane. Methane when treated with chlorine, it is in presence of sunlight. It is called chlorination. What will form? CS3, Cl plus HCl. If the methane treated with or alkane treated with bromine, it is called bromination. Bromination in presence of sunlight, it forms CS3Br plus HCl HBr. Right. For example, I have taken alkane treated with iodine in presence of sunlight. It forms iodoalkane. The byproduct is hydrogen iodide. Hydrogen iodide. It is called iodination because reaction with iodine. Sorry. Here, this reaction, it is a reversible reaction. It is a reversible reaction. Why? What is the reason? Because in this reaction, the byproduct is hydrogen iodide. This fellow, it is a strong reducing agent. Strong reducing agent. This fellow, strong reducing agent. It can reduce CH3I into CH4 and iodine in backward direction. Hence, we can get less yield of CH3. We cannot get good yield. We can get less yield, less amount of yield. To get good yield, we have to remove this fellow. It is a strong by adding. We can remove this fellow by adding strong oxidizing agents. Strong oxidizing because it is a reducing agent. So which one can fight with strong reducing agent? Strong oxidizing agent like HNO3, HiO3, HiO4, iodic acid, periodic acid, HGO. All these are strong oxidizing agents. Okay, these strong oxidizing agents can react with HA, sun, and these oxidizing agents can destroy hydrogen iodide. How does? For example, HA reacts with HiO3. This oxidizing agent can oxidize hydrogen iodide into iodine, and byproduct is water. Like this, these strong oxidizing agents can destroy hydrogen iodide and increase the yield of iodoalkane, the product of iodoalkane. Right. So now coming to chloroalkane, chlorination. I have taken methane when treated with chlorine in presence of sunlight. The product will be 4HF plus C. Here there is no chloro compound, there is no chloroalkane. So it is chlorination. When alkane treated with chlorine, we are not getting any chloroalkane because what is the reason? Chlorine is high reactivity towards hydrogen. Chlorine has high affinity towards hydrogen. It can react more effectively with hydrogen and it can form hydrogen chloride. Chlorine can react all hydrogen present on alkane. It can react all hydrogen present on alkane. It can produce hydrogen chlorides. And what we get, we get only carbon. So to get chloroalkane, what we do? At any cost I need chloroalkane from this method. What we do? We can do. So this is more reactivity. We have to reduce the reactivity. It is this fellow more hyperactive. This fellow hyperactive. We have to reduce the hyperactivity. So how can you reduce the activity of chlorine? By adding inert gases. If you add inert gases, it will dilute and the reactivity decreases. Then we can get chloroalkanes. But it is not. It is explosive reaction. That's why. So preparation of chloroalkanes and preparation of haloalkanes, these two methods are not suitable methods. We can prepare by halogen exchange method. We can prepare haloalkane and chloralkanes in good yield, right? So in next video we will discuss the halogen exchange methods, right? Now I wanted to discuss about alkyl halides, preparation of alkyl halides, allylic halides, preparation of allylic halides, For example, I have taken propene CH2 double bond CH single bond CH3 propene. When it is treated with chlorine in the presence of sunlight, at which carbon substitution takes place? This carbon, allylic carbon, or this carbon, or this carbon? At which carbon substitution takes place? Absolutely, so at this allylic carbon substitution takes place, because it forms a carbon radical. It is more stabilized by resonance with the double bond. Hence, substitution takes place at allylic carbon. CH2 double bond CH single bond CH2 Cl. Allylic chloride formed in this way. For example, I want to prepare allylic bromide. CH2 double bond CH CH3 when treated with bromine in presence of sunlight, we can get CH2 double bond CH CH2Br. So allylic bromide also we can prepare in alternative method by using N-bromosuccinimide NBS, CH2 double bond CH single bond CH3. By using NBS, N-bromosuccinimide, the structure is N-bromosuccinimide. It can provide bromine for allylic substitution. It will form the product of CH2 double bond CH CH2Br. N-bromosuccinimide. By using N-bromosuccinimide, we can get allylic bromide, right? So how can you prepare benzylic halides? For example, I have taken toluene CH3. When it is treated with halogen in presence of sunlight or high temperature, so what happens? Substitution takes place at benzyl carbon, because benzylic carbon radical is more stabilized by benzene ring due to resonance, and we can get benzylic halide CH2 Cl, benzylic halide, right? So in this way you can explain about halogenation of alkanes. Now we discuss about some previous year questions, right? Right, first question. Question number 1. PYQs. First question. Total number of isomeric compounds. Including stereoisomers. Including stereoisomers formed by monochlorination of 2-methyl butane is this. It is one of the numerical question from JEE Mains 2024. He is asking total number of isomeric compounds formed by monochlorination of 2-methyl-butane, including stereoisomers. Right. First we have to write 2-methyl-butane, CH3, CH, CH, CH3, CH2, CH3. It is a 2-methyl-butane. On chlorination in presence of sunlight, how many isomeric products will form? Check. Here substitution takes place at this carbon. 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 Either this carbon or this carbon. Both are symmetric. Okay. Now if the substitution takes place at first carbon, so what product will form? CH3, CH, CH3, CH2, CH2, Cl. If the substitution takes place at second carbon, what product will form? CH3, CH, CH3, CH, Cl, CH3. If the substitution takes place at third carbon, so what product will form? CH3, C, Cl, CH3, CH2, CH3. If the substitution takes place at fourth carbon, it forms CH3, CH2Cl, CH, CH3, CH2, CH3. Here 4 isomers forms, but we have to check stereoisomers. Stereoisomers means if any compound contains chiral carbon, it can form some dextro and levo isomers. For example, so does it contains any chiral carbon? What is chiral carbon? If the carbon attached to 4 different groups, that is chiral carbon. If any compound contains chiral carbon, it can form stereoisomer. It can form dextro and levo form. So there is no chiral carbon. Here one check. It has one chiral carbon. It can form dextro and levo form. Here there is no chiral carbon. Here it contains chiral carbon. So it also can form dextro and levo forms. Total how many isomers? 1, 2, 3, 4, 5, 6. Total isomers 6. It is excellent question, right? Now coming to second question. Coming to second question. Two-methyl butane on reaction with bromine. 2-methyl butane on reaction with bromine Br2 in the presence of H nu, that means sunlight, gives major product is options given. 1 bromo 3-methyl butane, 1 bromo 3-methyl butane. Option B, 2 bromo 3-methyl butane, 2 bromo 3-methyl butane. Option C, 2 bromo 2-methyl butane, 2 bromo 2-methyl butane. Option D, 1 bromo 2-methyl butane, 1 bromo 2-methyl butane. So 2-methyl butane on reaction with bromine, we have to take 2-methyl butane, CH3, CH, CH3, CH2, CH3. It is 2-methyl butane. So on reaction with bromine in presence of sunlight. So what is the major product? Here 1 degree carbon, 2 degree carbon, 3 degree carbon, 1 degree carbon. Which is more reactive? Which is more reactive carbon? 3 degree carbon. It contains 3 degree hydrogen. 3 degree hydrogen is more reactive than 2 degree and 1 degree. Hence substitution takes place at 3 degree carbon. CH3, C, CH3, bromination, CH2, CH3. It is 2 bromo 2 methyl butane. It is 2 bromo 2 methyl butane. Option C is correct answer. Next, coming to third question. Which of the following? So which of the following isomer produce? Which of the following isomer produce only one product? Only one product in monohalogenation. In monohalogenation. Which of the following isomer produce only one product in monohalogenation? He gives some isomers. Option A, CH3, CH2, 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 CH3, pentane and pentane. Option B, CH3, CH, CH3, CH2, CH3, 2-methyl butane. Option C, CH3, C, CH3, CH3, CH3. It is called neopentane. So in which option D, none of the above. So in which case only one product will produce in monohalogenation. One check option A, monohalogenation, on halogenation. So this carbon substitution takes place, and this carbon substitution takes place, and this carbon substitution takes place. It can form three products. So if you take this compound, this carbon substitution takes place, and this carbon substitution takes place, and this carbon substitution takes place, and this carbon substitution takes place. It forms 4 products. Coming to option C. So here 4 symmetric carbons, 1, 2, 3, 4, 4 symmetric carbons, and there is no hydrogens at this carbon. So it forms only one product in halogenation. So option C is the correct answer. In this way, we can explain about halogenation of alkanes and arenes. And thank you for watching.